Close your eyes and feel the weight of your body against the bed. You are resting on something magnificent. Something ancient. Something that holds secrets we are only beginning to understand. Right now, as you breathe slowly and deeply, you are lying on the surface of a planet that spins through space at incredible speeds. Yet you feel perfectly still. Perfectly safe. The Earth cradles you like a gentle giant, holding you close with invisible arms we call gravity. But what if I told you that deep beneath you, deeper than any human has ever traveled, there might be something truly extraordinary hiding in the darkness? Something so strange that it sounds like science fiction, yet so real that scientists around the world are searching for it right now. Imagine, for a moment, that you could shrink down to the size of a grain of sand. Now imagine shrinking even smaller. Smaller than the tiniest ant. Smaller than a single cell. Smaller than anything you can see, even with the most powerful microscope. At that impossible size, you might discover something that shouldn't exist. Something that bends the rules of everything we know about our world. A tiny black hole, no bigger than an atom, quietly living at the center of our planet. This sounds impossible, doesn't it? Black holes are supposed to be massive monsters in space. They swallow entire stars. They are born when giant suns collapse and die. They live in the cold, empty darkness between galaxies, far from our warm, living world. Yet some of the smartest people on Earth think differently. They believe that not all black holes are giants. Some might be tiny, microscopic. And some of these microscopic black holes might have found their way into the heart of our planet billions of years ago, when the Earth was young and still forming from cosmic dust. Think about this as you rest here in the darkness. Beneath your body, beneath the floor, beneath the soil and rock and underground rivers, the Earth stretches down for thousands of miles. It's like an onion made of stone and metal, with layer after layer of different materials. The deeper you go, the hotter it becomes. The deeper you go, the more the rock changes. First soil, then solid rock, then rock so hot it flows like thick honey. And finally, at the very center, a ball of iron hotter than the surface of the sun. This iron heart of our planet spins and churns. It creates the magnetic field that protects us from dangerous radiation from space. It's been spinning for billions of years, since before there was life on Earth. Since before there were oceans or clouds or the first simple creatures in ancient seas. And in that spinning heart of iron, something impossible might be hiding. Scientists call these theoretical objects primordial black holes. Primordial means from the very beginning. These are black holes that might have formed in the first moments after the universe began, when everything was squeezed together tighter than anything we can imagine today. Picture the entire universe smaller than the period at the end of this sentence. In that incredible squeeze, in that moment of pure creation, tiny black holes might have popped into existence like bubbles in boiling water. Most would have been destroyed immediately. But some might have survived. These survivors would be incredibly small but incredibly dense. Imagine something with the mass of a mountain squeezed into a space smaller than an atom. The gravity around such an object would be so strong that nothing could escape it. Not light. Not matter. Not even time itself would flow normally near its edge. If one of these ancient travelers found its way to Earth billions of years ago, it would have sunk straight through rock and soil like a stone falling through water. Nothing could stop it. It would have fallen all the way to the center, where it would remain, trapped by its own journey. But here's the beautiful mystery that helps you rest peacefully tonight. If such a thing exists in our planet's heart, it's not dangerous to us up here on the surface. It would be far too small to hurt anything. Instead, it would be like a tiny, quiet neighbor, living peacefully in the deep, warm darkness below. It might even be helpful. Some scientists think that if a tiny black hole lives in Earth's core, it could help explain some of the strange things we've noticed about our planet. It might help explain why Earth's magnetic field behaves the way it does. It might help explain some of the mysterious vibrations that travel through our planet's body. These are just ideas, of course. Beautiful possibilities. We don't know for certain if such things exist, But that's what makes science so wonderful. There are still mysteries all around us. Still questions waiting for answers. Still incredible discoveries waiting to be made. As you lie here in the gentle darkness, feeling the solid earth beneath you, you can smile at this thought. You live on a planet that might hold impossible secrets. A world that has protected and nurtured life for billions of years, while quietly keeping the most extraordinary mysteries locked away in its deepest, most hidden places. The Earth that holds you so gently might be more amazing than we ever imagined. And tomorrow, scientists around the world will wake up and continue their patient search for answers. They will study the deepest earthquakes. They will measure the tiniest changes in gravity. They will listen for whispers from the deep. But tonight, you can rest peacefully on this magnificent, mysterious world, knowing that even if we don't understand everything about our planet yet, we are held safely in its ancient, loving embrace. Somewhere far below, in chambers of liquid iron hotter than any fire, the impossible might be waiting patiently for us to find it. To understand how something impossible might be hiding in our Earth's heart, we need to travel far from your warm bed tonight. We need to journey to the stars themselves, where the most incredible story in the universe unfolds again and again. Look up at the ceiling above you and imagine it melting away into the night sky. Picture the stars scattered like diamonds on black velvet. Each tiny point of light is actually a massive ball of fire, burning with the power of millions of atomic bombs every single second. But stars, like all living things, are born, they grow, they age, and eventually, they die. The death of a star is perhaps the most beautiful and terrifying event in all of nature. It's a story of collapse and creation, of endings that become beginnings, of matter pushed to the very edge of what's possible. Most stars live quiet, steady lives for billions of years. Our own sun is like this. It burns its fuel slowly and gently, warming our days and lighting our world. When stars like our sun finally grow old and tired, they simply fade away like dying embers in a fireplace. They become small, dense objects called white dwarfs, no bigger than Earth but containing almost all of the sun's original mass. But some stars are different. Some stars are giants beyond imagination. If you could replace our sun with one of these monster stars, it would stretch past the orbit of Mars. These giants burn their fuel fast and bright, living wild, intense lives that last only a few million years instead of billions. When a giant star begins to die, something extraordinary happens. The nuclear fire in its core starts to flicker and fade. For its entire life, this fire has been pushing outward, fighting against the star's own crushing weight. The fire and gravity have been locked in perfect balance, like two people pushing against each other with exactly equal strength. But when the fuel runs out, the balance breaks. Gravity wins. And when gravity wins against something that massive, the results are beyond anything we can truly imagine. The core of the dying star collapses. Not slowly, like a building being demolished. Not gradually, like a deflating balloon. It collapses so fast that if you could somehow watch it happen, you would see the entire center of a star, something bigger than our entire Earth, crushed down to the size of a city in less time than it takes you to blink your eyes. In that moment of collapse, the matter gets squeezed tighter than anything else in the universe. Imagine trying to crush a car down to the size of a marble. Now imagine that marble contains all the weight of the original car. That's what happens to the matter in a collapsing star, except the crushing is millions of times more extreme. The gravity becomes so strong that it starts to bend space itself. You know how a heavy ball creates a dip when you place it on a stretched rubber sheet? The collapsed star does something similar to the fabric of space and time, but the dip becomes so deep that it's more like a bottomless hole. This is how a black hole is born. From the death of a giant star comes something that defies our everyday understanding of reality. A region where gravity is so powerful that nothing can escape. Not rocks, not gas, not even light itself. If light cannot escape, then we cannot see inside. That's why we call them black holes. They are holes in space that appear perfectly black because no light can travel from them to our eyes. But here's where the story becomes even more amazing. Scientists have discovered that not all black holes are created from dying stars. Some might be much, much older. Some might have been born in the very first moments after the universe began, when everything was squeezed together in ways that make even collapsing stars seem gentle. These ancient black holes, the primordial ones we whispered about in the last chapter, would be completely different from their stellar cousins. Instead of being born from the collapse of something enormous, they would have been born from the incredible conditions of the early universe itself. Picture the entire universe as a single point, smaller than the smallest thing you can imagine. In that impossible compression, fluctuations in density could have created tiny regions where matter was squeezed even tighter than everything else around it. These regions could have become the seeds of black holes, but black holes unlike any others. While stellar black holes are massive, often containing the mass of many suns, these primordial black holes could be tiny. Some might contain the mass of a mountain compressed into a space smaller than an atom. Others might be even smaller, containing the mass of a large building squeezed into a space smaller than the nucleus of a single atom. These tiny black holes would be just as impossible as their giant cousins, but in completely different ways. They would have the same strange properties, the same ability to bend space and time, the same power to trap light and matter, but they would be small enough to hide almost anywhere. Small enough, perhaps, to sink through solid rock. Small enough to travel through space for billions of years without being noticed. Small enough to fall into a young planet and settle quietly in its core, waiting patiently in the hot iron darkness. The universe is full of these extremes. Giant stars that burn brighter than entire galaxies. Tiny particles smaller than atoms that somehow contain the building blocks of everything we see. Regions of space where time itself flows differently than it does here in your peaceful bedroom. It's a universe that loves to create impossible things. A universe where the death of something beautiful can give birth to something even more mysterious and wonderful. As you rest here tonight, you are connected to this cosmic story of creation and collapse, of matter pushed to its absolute limits, and of mysteries that hide in the spaces between what we know and what we dream might be possible. Somewhere in the darkness above your ceiling, new stars are being born while others are beginning their final, spectacular dance toward forever. Mathematics is the secret language of the universe. As you lie here in the gentle darkness, numbers and equations are quietly describing every breath you take, every beat of your heart, every movement of the Earth as it spins through space. But some mathematical ideas are so strange, so beautiful, that they seem more like dreams than reality. The mathematics that describes black holes is like this. It takes us into a world where our everyday understanding breaks down completely, where time and space dance together in ways that sound impossible. Imagine you could see mathematics the way you see colors. Picture the numbers that describe a simple thing, like the speed of your bicycle, as gentle blues and greens. The mathematics of everyday life would be filled with soft, familiar colors that make perfect sense. But the mathematics of black holes would be different. It would shimmer with impossible colors that your eyes have never seen. Colors that exist only in the realm of pure thought, where reality stretches beyond anything we experience in our daily lives. Over 100 years ago, a gentleman named Albert Einstein discovered something extraordinary about space and time. He realized that they are not separate things, like we once believed. Instead, they are woven together into a single fabric, like threads in a cosmic tapestry. Einstein called this fabric space-time. And he discovered that massive objects, like stars and planets, actually bend this fabric. Picture a bowling ball placed on a stretched rubber sheet. The heavy ball creates a dip in the sheet. Other smaller balls rolled nearby will curve around the dip, drawn toward the heavier ball. This is how gravity really works. The Earth curves the space-time around it, and you are following that curve. That's why you feel pulled toward the ground. You're not being pulled by a mysterious force. You're simply following the curved path that the Earth's mass has created in the fabric of reality itself. But when Einstein's mathematics is applied to something as extreme as a black hole, the results become almost magical. The equations tell us that near a black hole, space and time behave in ways that seem to break all the rules we learned growing up. Close to a black hole, time itself begins to slow down. If you could somehow hover safely near the edge of one of these cosmic monsters, and you had a friend watching you from far away, something incredible would happen. Your friend would see you moving more and more slowly, like a movie being played in slow motion. To you, everything would feel perfectly normal. Your watch would tick at its regular pace. Your heart would beat normally. But to your distant friend, each tick of your watch would take longer and longer. Each heartbeat would stretch out like a note from a violin held forever. This isn't science fiction. This is what Einstein's mathematics tells us must happen. Time is not the steady, unchanging thing we imagine it to be. Near a black hole, time becomes like thick honey, flowing slower and slower as you approach the edge. The edge of a black hole has a special name. Scientists call it the event horizon. It's the boundary between the normal universe and the region where nothing can escape. Cross that invisible line, and you've entered a realm where the mathematics becomes even stranger. At the event horizon, something remarkable happens to space itself. The equations tell us that space begins to fall inward faster than light can travel outward. Imagine standing in a river where the current is stronger than you can swim. No matter how hard you try to swim upstream, you get carried along by the flowing water. Near a black hole, space itself flows like that river. And once you cross the event horizon, space flows inward faster than light itself can swim against it. That's why nothing can escape. Even light, the fastest thing in the universe, gets swept along by the flowing current of space. But here's where the story becomes even more beautiful and strange. The mathematics tells us that different types of black holes exist, each with their own special properties. The massive ones born from collapsing stars spin slowly and majestically, like cosmic whirlpools in the fabric of space-time. But tiny primordial black holes, if they exist, would be completely different. Some might spin so fast that they blur the boundary between what's inside and what's outside. Others might be perfectly still, like microscopic pearls of pure gravity hidden in the depths of our world. The equations that describe these tiny black holes are elegant in their simplicity. Unlike their massive cousins, which can be seen from great distances as they devour matter and light, primordial black holes would be nearly invisible. They would sit quietly in space, or perhaps in the heart of a planet, barely interacting with the world around them. Their gravity would still follow Einstein's rules. Space and time would still bend around them in the same impossible ways. But because they're so small, their effects would be felt only in the tiniest, most delicate measurements. Scientists have calculated that a primordial black hole with the mass of a mountain, compressed into a space smaller than an atom, could exist at the center of our Earth for billions of years without causing any problems. It would be like having a microscopic pocket of pure mathematics sitting in the molten iron of our planet's core. The numbers tell us that such an object would be stable. It wouldn't grow larger by eating the iron around it, because the iron would be moving too fast to fall in. It wouldn't evaporate away, because it would be too massive to disappear quickly. It would simply exist, quietly warping space and time in a region smaller than you can imagine. This is the strange beauty of mathematical truth. The equations don't care whether something sounds impossible to our everyday minds. They simply describe what must be true, regardless of whether we can easily picture it or understand it with our ordinary senses. The mathematics of black holes has predicted many things that seemed impossible when they were first discovered on paper. It predicted that space and time could be bent and stretched. It predicted that time could slow down. It predicted that nothing could escape from certain regions of space. All of these predictions seemed like pure fantasy when Einstein first wrote them down. But one by one, scientists have found ways to test them. And one by one, the impossible has turned out to be beautifully, mysteriously true. As you rest here tonight, the same mathematical laws that describe the most extreme objects in the universe are also describing the gentle rise and fall of your chest as you breathe. Mathematics is the thread that connects the smallest and largest things in existence. And perhaps, somewhere in the flowing equations that describe our world, there are clues waiting to tell us whether something truly impossible lives quietly in the heart of our home planet. To understand how something impossible might live in Earth's heart, we need to travel back to the very beginning of everything. Back to a time before stars, before planets, before even the smallest atoms existed. Back to the moment when the entire universe was smaller than the period at the end of this sentence. Close your eyes and try to imagine nothing. Not darkness, because darkness is still something. Not empty space, because even empty space takes up room. Try to imagine absolute nothing at all. This is harder than it sounds, isn't it? Our minds struggle to picture true nothingness because we've never experienced anything like it. Now imagine that from this perfect nothingness, everything suddenly appeared. Not just our planet and our sun, but every star in every galaxy, all of space itself, and even time. All of it bursting into existence in a single moment of pure creation. Scientists call this moment the Big Bang, though it wasn't really a bang at all. There was no sound, because there was no air to carry sound waves. There was no explosion happening in space, because space itself was being born in that same instant. It was more like the universe suddenly deciding to exist. In that first incredible moment, everything that would ever exist was squeezed together tighter than anything your mind can truly grasp. The entire universe was hotter than the center of any star. It was denser than anything we see today. It was a single point of pure energy and possibility. But the universe couldn't stay that way. It immediately began to expand, like the ultimate balloon being inflated at impossible speed. As it grew, it began to cool. As it cooled, the first particles began to form. And in those first few moments of expansion and cooling, something remarkable might have happened. Picture a pot of water beginning to boil. At first, the water is smooth and calm. But as it heats up, small bubbles start to form. These bubbles are regions where the water is slightly different from everything around it. Some bubbles grow and rise to the surface. Others collapse and disappear. In the early universe, something similar might have happened. As space itself was expanding and cooling, tiny regions might have become slightly denser than everything around them. Most of these dense spots would have smoothed out as the universe continued to grow. But some might have become so dense that they collapsed into the first black holes. These would not be the massive black holes born from dying stars. Those wouldn't exist for hundreds of millions of years, until the first stars formed and lived their lives. These primordial black holes would be completely different creatures, born from the wild conditions of creation itself. Some of these ancient black holes might have been truly tiny. Smaller than atoms, yet containing the mass of mountains. Others might have been larger, containing the mass of planets or even stars, but still much smaller than the stellar black holes that would come later. Think of them as seeds scattered through the expanding garden of space. Most would have been alone in the cosmic darkness, drifting between what would eventually become galaxies. But some might have found their way into regions where matter was beginning to clump together, where the first clouds of gas were starting to condense. Billions of years later, when our own solar system was forming from a vast cloud of dust and gas, some of these ancient travelers might have been swept up in the process. Picture a tiny black hole, older than our sun, older than any planet, quietly drifting through the swirling cloud that would become our home. As the cloud collapsed to form the sun and planets, this microscopic visitor would have been pulled along. It would have had no choice but to fall toward whatever massive object was forming nearby. If it fell toward the growing Earth, it would have sunk straight through the accumulating rock and metal, coming to rest at the very center of our forming world. There it would remain, a primordial echo from the birth of the universe, quietly existing in the hot iron heart of our planet. It would be like finding a fossil from the very first moments of creation, preserved in the deepest possible place. The beautiful thing about this idea is how patient these objects would be. A primordial black hole would not be hungry like the massive ones we see in space. It would not devour everything around it. The material in Earth's core would be moving far too quickly to fall into something so small. Instead, it would sit peacefully in the flowing iron, occasionally capturing a single atom here or there, but mostly just existing as a tiny point of impossible density. It would warp space and time in its microscopic neighborhood, but the effects would be so small that they would barely influence anything else. For over 4 billion years, such an object could have been our silent companion. It would have been present when the first oceans formed. It would have been there when life first appeared in ancient seas. It would have existed through the age of dinosaurs, through ice ages, through the rise of humanity, through every moment of Earth's long story. And we would never have known it was there. It would have been our planet's deepest secret, a whisper from the beginning of time, hidden in the one place where we could never directly look. This is the wonder of primordial black holes. They connect us to the very first chapter of the universe's story. They are living reminders that our cosmos has a history stretching back to moments so early, so extreme, that they challenge everything we think we know about reality. If one of these ancient objects really does live in Earth's core, it would mean that our planet carries within it a piece of creation itself. A fragment of the universe's birth, preserved in iron and heat and darkness, waiting for us to become clever enough to detect its presence. The idea fills scientists with excitement and wonder. It suggests that the answers to some of our deepest questions about the universe might be found not by looking up at distant stars, but by looking down into the mysterious heart of our own world. As you rest here tonight, you might be lying above one of the universe's oldest secrets, a primordial echo that has been patiently waiting for billions of years. Imagine your body as a vast continent. Your skin would be the surface where people live and work. Your bones would be the mountain ranges deep below. And at your very center, where your heart beats steadily in the darkness, would be something like Earth's core, the hidden engine that keeps everything alive. But Earth's heart is far more mysterious and powerful than anything in your body. As you lie here breathing softly, 6,000 kilometers straight down through rock and metal and heat, something extraordinary spins in perfect darkness. The journey to Earth's center would be like traveling to another world entirely. For the first few dozen kilometers, you would pass through familiar territory, soil and rock, underground rivers and caves, fossils of ancient creatures sleeping in stone. But as you travel deeper, the rock around you would begin to change. The temperature would rise steadily, like descending into a vast oven. The pressure would grow so intense that the hardest diamonds would be crushed like soft clay between invisible fingers. At about 30 kilometers down, the rock would become so hot that it would glow red, then orange, then white. Yet it would remain solid, held in place by the incredible weight of everything above it. This is the realm of the deep Earth, where familiar rules begin to break down. Deeper still, at nearly 3,000 kilometers down, you would reach a boundary that divides our planet into two completely different worlds. Above this line, everything is rock, hot rock, flowing rock, rock under pressure, but still recognizably rock. Below this line lies something else entirely. Here begins Earth's core, a sphere of metal suspended in the planet's center like a ball bearing in the heart of a vast machine. This metal sphere is larger than the planet Mars. It contains more iron than exists in all the rest of our solar system combined. And it spins. The outer part of this metallic heart is liquid iron so hot that it flows like water, yet so dense that a single spoonful would weigh more than a brick. This liquid iron ocean churns and swirls in patterns too complex for any computer to fully predict. Currents of molten metal race around the spinning core at speeds that would make hurricane winds seem gentle. But at the very center, where the pressure becomes so extreme that not even liquid can exist, the iron becomes solid again. This innermost core is a crystal of pure iron, nearly as hot as the surface of our sun, spinning slightly faster than the rest of the planet. It's like a solid metal moon orbiting within Earth's liquid iron heart. This spinning, flowing metal is what creates Earth's magnetic field, the invisible shield that protects us from harmful radiation streaming from space. The moving iron acts like a vast electrical generator, creating currents that reach far beyond our planet's surface. These currents form the magnetic field that makes compass needles point north, that guides migrating birds, that creates the beautiful dancing lights we call aurora in polar skies. For over 4 billion years, this metal heart has been beating steadily, spinning and generating the magnetic field that makes life possible on Earth's surface. Without it, the solar wind would strip away our atmosphere. Our beautiful blue sky would fade to black. The oceans would boil away into space. But now imagine something even more extraordinary hidden in this realm of liquid iron and impossible heat. Picture a primordial black hole, smaller than an atom but containing the mass of a mountain, resting quietly at the very center of Earth's spinning core. Such an object would have found its way here billions of years ago, when the Earth was still forming from cosmic dust. It would have sunk through the gathering material like a stone falling through water, coming to rest at the exact center of our growing world. In this position, it would be perfectly balanced. The gravity pulling it in every direction would cancel out, leaving it suspended in the geometric heart of our planet. Here it would remain, neither rising toward the surface nor sinking any deeper, held in place by the symmetry of Earth's own mass. The liquid iron flowing around it would be far too hot and fast-moving to fall into such a tiny gravitational well. The black hole would capture only the occasional atom, growing so slowly that it would barely change at all over billions of years. It would be like a microscopic island of impossibility in an ocean of flowing metal. But its presence might explain some of the mysterious things scientists have noticed about our planet. Perhaps the tiny gravitational effects of such an object help to stabilize Earth's magnetic field. Perhaps its influence on the flowing iron creates some of the complex patterns we see in the planet's magnetic behavior. These are still just beautiful possibilities, of course. But they remind us that even our home planet holds secrets we've barely begun to understand. The Earth that feels so solid and familiar beneath your body is actually a complex, dynamic system with a hidden engine more powerful than anything humans have ever built. As you rest here tonight, that engine continues its ancient work. The iron core spins in its molten metal dreams, generating the invisible forces that keep our world alive. Currents of liquid metal, heated by the slow decay of radioactive elements and perhaps by the primordial heat of Earth's formation, continue their eternal dance in the darkness below. And perhaps, in the very center of it all, something impossible waits patiently in the heart of iron, a visitor from the dawn of time, keeping its quiet vigil in the deepest place on Earth. The solid ground beneath your bed is actually the thin, cool crust floating on an ocean of rock and metal that extends almost all the way to the center of our world. Right now, as you rest peacefully in your bed, you are experiencing one of the most mysterious forces in the entire universe. It's so gentle that you barely notice it, yet so powerful that it shapes the destiny of stars and galaxies. It's holding you softly against your mattress, keeping your feet on the ground, and binding every atom in your body together in perfect harmony. This force is gravity, and it whispers its secrets through every moment of your life. Feel the weight of your head against your pillow. That gentle pressure is gravity speaking to you in its quiet language. Feel how your body settles naturally into the bed, how your arms rest heavily at your sides. These sensations are conversations between your matter and the Earth's matter, conducted through the invisible medium of curved space-time. But gravity is far stranger and more beautiful than most people realize. It's not really a force pulling you downward, like an invisible hand tugging at your clothes. Instead, gravity is the shape that mass gives to the universe itself. Imagine you're lying on a trampoline, and someone places a heavy bowling ball in the center. The rubber surface would curve and dip around the ball. Now imagine rolling a marble across that curved surface. The marble would naturally follow the curves, circling around the bowling ball in graceful loops. This is exactly how gravity works, except instead of a trampoline, we're talking about the fabric of space and time itself. Every object with mass, from the tiniest grain of sand to the most massive star, creates curves and dips in this cosmic fabric. Other objects simply follow those curves, like the marble following the shape of the curved trampoline. The Earth creates a deep, smooth curve in space-time, and you are following that curve. That's why you feel pulled toward the ground. You're not being yanked downward by a mysterious force. You're simply taking the straightest possible path through curved space, and that path happens to lead toward Earth's center. But here's where the story becomes truly magical. Gravity speaks in whispers so soft that we need the most sensitive instruments ever built to hear them. When two massive objects orbit each other far out in space, they create tiny ripples that spread through the fabric of space-time itself, like waves spreading across the surface of a still pond. These gravitational waves travel at the speed of light, carrying messages about cosmic events happening billions of light-years away. When two black holes collide and merge in a distant galaxy, the waves from that collision eventually reach Earth, causing every atom in your body to stretch and compress by amounts smaller than 1/1000th of the width of a proton. Scientists have built incredible machines that can detect these whispers from space. The machines are so sensitive that they can measure changes in distance smaller than anything you can imagine. They can detect when the space between two mirrors changes by less than 1/10,000th the width of a single proton. When these machines detect gravitational waves, they're essentially listening to the universe's heartbeat. They hear the final moments of colliding black holes, the birth cries of neutron stars, and perhaps even echoes from the first moments after the Big Bang itself. But gravity has an even more personal connection to the mystery we've been exploring. If a tiny primordial black hole really does exist in Earth's core, its gravity would be whispering to us constantly. The effect would be incredibly subtle, but it might be detectable if we knew exactly what to look for. Think of Earth as a giant musical instrument, like a bell or a drum. When something disturbs it, an earthquake, a large explosion, even the gravitational pull of the moon, the entire planet rings like a bell. These vibrations travel through solid rock and liquid iron, carrying information about everything they pass through. A tiny black hole at Earth's center would subtly change the way our planet rings. It would be like having a small, incredibly dense bead at the center of a bell. The vibrations would travel slightly differently, creating a unique signature that sensitive instruments might be able to detect. Scientists are also looking for other gravitational whispers that might reveal the presence of such an object. They study how Earth's gravitational field changes over time, measuring variations so small that they require satellites orbiting high above our atmosphere to detect them. They watch for tiny changes in how space and time behave near our planet's surface. If a primordial black hole exists in Earth's core, it would create minute distortions in space-time that might be measurable with future technology. The gravity from such an object would also affect the way matter behaves deep inside our planet. It might influence the flow patterns of the liquid iron in Earth's outer core, subtly changing the magnetic field that protects us from harmful radiation from space. These effects would be incredibly small, so small that detecting them would require pushing the boundaries of what's scientifically possible. But that's what makes the search so exciting. Scientists love challenges that force them to build new instruments, develop new techniques, and think in completely new ways. The beautiful thing about gravity is that it connects everything in the universe. The same force that keeps your feet on the ground also guides planets in their orbits around stars. The same curved spacetime that you're resting in right now extends all the way to the edge of the observable universe. Every atom in your body is part of this cosmic conversation. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it was forged in the hearts of ancient stars. And all of it responds to gravity's gentle whispers, participating in the great dance of matter and spacetime that has been going on for billions of years. If you could somehow become sensitive enough to feel gravitational waves directly, you would experience the universe in an entirely new way. You would feel the collisions of black holes as gentle tremors passing through your body. You would sense the spin of neutron stars as rhythmic pulses in space-time itself. And perhaps, if you became sensitive enough, you might even feel the tiny gravitational whispers coming from deep within our own planet. You might detect the subtle influence of something impossible, something ancient, something that has been quietly sharing our world for longer than life has existed on Earth's surface. As you settle deeper into sleep tonight, your body continues its eternal conversation with gravity, responding to curves in space-time that connect you to every star and galaxy in the cosmic web. In quiet laboratories around the world, while you sleep peacefully in your bed, scientists are conducting some of the most delicate experiments ever attempted. They are treasure hunters searching for something that might not even exist, using instruments so sensitive they can detect changes smaller than anything your imagination can grasp. These modern explorers don't dig through sand or sail across oceans looking for buried gold. Instead, they listen to the Earth's heartbeat, measure its breathing, and watch for the tiniest trembles that might reveal secrets hiding in our planet's deepest places. Picture a doctor listening to your heart with a stethoscope. The doctor hears the steady rhythm of your heartbeat and can tell whether everything is working normally or if something unusual is happening inside your chest. Scientists studying Earth do something remarkably similar, but instead of listening to a heart, they're listening to an entire planet. Deep beneath the mountains of Italy, in tunnels carved through solid rock, scientists have built laboratories that exist in almost perfect silence. Here, far from the vibrations of traffic, the trembling of footsteps, and even the whisper of wind through trees, incredibly sensitive instruments wait patiently for signals from the deep earth. These underground laboratories are like quiet temples dedicated to the search for invisible treasures. The rock walls are thick enough to block almost all interference from the busy world above. In this profound stillness, scientists can detect gravitational waves from colliding black holes billions of light-years away, and measure changes in Earth's gravity so small that they would be impossible to notice anywhere else. One type of detector looks like a massive letter L made of concrete and steel, with arms stretching several kilometers in different directions. Laser beams travel back and forth through vacuum chambers, measuring the distance between mirrors with impossible precision. When a gravitational wave passes through Earth, it stretches and compresses space itself by amounts tinier than the width of a single proton. If these waves carry any signature from a primordial black hole hiding in Earth's core, these instruments might be the first to detect it. The waves would arrive carrying information encoded in their gentle stretching and squeezing of space-time, like messages written in a language of pure geometry. Other scientists take a completely different approach. They study Earth the way a musician might study a guitar, listening to the natural frequencies at which our planet vibrates. Every earthquake, every large storm, every impact from space causes Earth to ring like an enormous bell, and these vibrations carry information about everything inside our world. Imagine trying to figure out what's inside a wrapped present by shaking it and listening to the sounds it makes. Scientists do something similar with Earth, except instead of shaking it, they listen to how it responds to natural events like earthquakes and ocean storms. The presence of something as strange as a tiny black hole at Earth's center would subtly change these vibrations. It would be like having a small, incredibly dense marble at the heart of a ringing bell. The change would be almost impossibly small, but with sensitive enough instruments, it might be detectable. In laboratories in Japan, scientists have built underground chambers where they float massive mirrors in perfect vacuum, isolated from every possible vibration except the ones they want to measure. These mirrors hang from sophisticated suspension systems that filter out the constant trembling of Earth's surface, leaving only the deep, slow movements that might reveal our planet's hidden secrets. High above Earth's surface, satellites orbit in the cold vacuum of space, carrying instruments that can measure our planet's gravitational field with extraordinary precision. These space-based detectors map tiny variations in Earth's gravity, looking for patterns that might reveal dense objects hidden deep below the surface. From orbit, these satellites can detect gravitational anomalies caused by underground rivers, buried mountain ranges, and even changes in the amount of ice at the polar caps. If a primordial black hole exists in Earth's core, it might create a gravitational signature unique enough for these orbital detectives to identify. The search involves patience on a scale that's hard to imagine. Some experiments run continuously for years, collecting data point by precious data point, building up enough information to separate real signals from random noise. It's like trying to hear a whisper in a room full of people having loud conversations. Scientists also use computer models to predict exactly what kind of signals they should look for. They simulate Earth with and without a tiny black hole at its center, calculating how the presence of such an object would affect everything from seismic waves to magnetic field patterns. These simulations require some of the most powerful computers in the world, running calculations that model the behavior of matter under conditions that exist nowhere else in the solar system. The computers create virtual Earths, complete with flowing liquid iron cores, shifting tectonic plates, and all the complex interactions that make our planet a living, breathing system. But perhaps the most beautiful aspect of this search is how it brings together knowledge from completely different areas of science. Experts in gravitational physics work alongside geologists who understand earthquake patterns. Astronomers who study distant black holes collaborate with engineers who build the most precise measuring instruments ever created. The search for primordial black holes has also led to unexpected discoveries about our planet itself. The incredibly sensitive instruments built to detect these hypothetical objects have revealed new details about Earth's deep structure, helped scientists better understand earthquake patterns, and provided new insights into how our planet's magnetic field is generated. Even if the search never finds evidence of a primordial black hole in Earth's core, the quest itself has value. It pushes the boundaries of what's scientifically possible, forces us to develop new technologies, and deepens our understanding of the world we call home. The scientists conducting these experiments know that they might be searching for something that doesn't exist. But they also know that some of the greatest discoveries in science have come from looking for things that seemed impossible, using instruments that pushed the limits of human ingenuity. Tonight, while you drift toward sleep, these cosmic detectives continue their patient vigil. In underground laboratories and orbiting satellites, in computer simulations and theoretical calculations, the search for invisible treasures continues. They are listening to Earth's deepest songs, waiting for the moment when our planet might finally whisper the secret it has been keeping at its heart. There's something both frightening and wonderful about the idea of a black hole living inside our Earth. When people first hear this possibility, they often feel a shiver of fear. The words black hole bring to mind images of cosmic monsters devouring everything in their path, tearing apart stars and swallowing entire solar systems. But the tiny black hole that might exist in Earth's heart would be nothing like these stellar giants. It would be more like a sleeping dragon, powerful beyond imagination yet bound by invisible chains that keep it perfectly harmless to the world above. Think of the difference between a wild tiger prowling through the jungle and a housecat sleeping peacefully by a warm fireplace. Both are predators with sharp claws and hunting instincts, but their size and circumstances make them completely different creatures. A primordial black hole in Earth's core would be like that sleeping cat, containing all the fundamental properties of its larger cousins, but too small and too well-fed to pose any threat. Let's explore why this microscopic darkness would be so beautifully harmless. First, consider its size. Even if it contained the mass of an entire mountain, it would be smaller than a single atom. The opening of its event horizon, the boundary beyond which nothing can escape, would be tinier than anything visible even under the most powerful microscopes. For something to fall into this tiny black hole, it would need to approach incredibly close. We're talking about distances measured in fractions of the width of atomic particles. In the churning, flowing iron of Earth's core, where atoms are moving at tremendous speeds due to the intense heat, the chances of any particle getting close enough to be captured are almost zero. Imagine trying to throw a grain of sand into a pinhole from across a football field, while a hurricane is blowing the sand around in wild circles. That's similar to how difficult it would be for matter in Earth's core to actually fall into a microscopic black hole, even if that black hole was sitting right there in the middle of everything. But let's say occasionally, maybe once every few years, a single iron atom does wander close enough to cross the event horizon. What happens then is both beautiful and strange. The atom doesn't simply disappear. Instead, as it falls toward the black hole center, it gets stretched and heated until it glows brighter than any light we know. This glowing, however, would be trapped forever inside the black hole's event horizon. No light can escape to tell us what's happening. The energy would simply add to the black hole's mass, making it grow by the tiniest imaginable amount. A mountain mass black hole might capture enough matter over the entire age of the Earth to grow by less than the mass of a few grains of sand. There's something deeply poetic about this invisible consumption. In the hottest, most hidden place on our planet, a visitor from the dawn of time might be slowly, patiently, almost imperceptibly growing, one atom at a time. It would be like watching a flower bloom in slow motion, except the blooming would take billions of years, and no human eye could ever witness it. The black hole would also be held perfectly in place at Earth's center by gravity itself. Because it sits at the exact middle of our planet, the gravitational pull from every direction cancels out. It's suspended in perfect balance, like a soap bubble floating in still air, unable to move in any direction. This gravitational prison is one of the most beautiful aspects of the whole idea. The same force that created the black hole, gravity, also becomes its gentle keeper. It ensures that this cosmic visitor can never wander away from its position at Earth's heart, never drift upward toward the surface where it might cause problems. Even more remarkably, the black hole might actually be helping to keep our planet stable. Some scientists think that its tiny gravitational influence could help regulate the flow patterns in Earth's liquid iron core. Like a small weight in the center of a spinning top, it might help our planet maintain the steady magnetic field that protects us from harmful radiation from space. The temperature around a tiny primordial black hole would be truly extreme. The few atoms that do fall in would be heated to temperatures far beyond anything that exists naturally on Earth's surface. Yet this incredible heat would be contained within a region smaller than an atomic nucleus, completely isolated from the rest of our world. It's strange to think that the most extreme conditions in our solar system might exist not on the surface of the Sun or in the crushing depths of Jupiter, but right here inside our own planet, in a space so small that millions of them could fit inside the period at the end of this sentence. There's also something comforting about the idea that such an object could exist peacefully at Earth's center for billions of years without causing any harm. It suggests that the universe, despite containing things that sound terrifying, actually operates according to laws that prevent chaos and destruction. The black hole would be dangerous only in the most theoretical sense. Its gravity would be no stronger than that of any other object with the same mass. If you could somehow replace it with an ordinary mountain, Earth's gravitational field would be exactly the same. The difference would be that the mountain would be spread out over a normal mountain-sized area, while the black hole would contain all that mass in an impossibly small space. This is the paradox of primordial black holes. They are both the most extreme objects possible and the most perfectly contained ones. They represent matter pushed to its absolute limit, yet bound by physical laws that keep that extremeness safely isolated from everything else. As you rest here tonight, consider the strange beauty of this possibility. Beneath you, in the deepest place on Earth, something that sounds like pure science fiction might be waiting peacefully, neither growing nor shrinking, neither moving nor changing, just existing as a permanent reminder of how wonderfully strange our universe can be. Perhaps the most dangerous thing isn't the black hole itself, but the way it challenges our imagination to accept that reality can be far more extraordinary than our everyday experience suggests. Listen carefully in the quiet of your bedroom. Can you hear your heart beating? Can you feel the gentle rhythm of your breath? Your body is constantly creating tiny vibrations, subtle movements that tell the story of life flowing within you. Earth does something remarkably similar, but on a scale so vast that we need special instruments to hear its whispers. Our planet is never truly still. Even when everything seems perfectly calm on the surface, Earth is humming with constant, gentle vibrations. These movements are so small that you can't feel them, but they're always there, like a quiet song that never stops playing. Every earthquake, every ocean wave crashing against the shore, every large storm that moves across the continents creates waves of energy that travel through solid rock. These seismic waves race through our planet at incredible speeds, carrying messages from one side of Earth to the other in just a few minutes. Think of Earth as an enormous musical instrument, like a giant bell or drum. When something strikes it, perhaps tectonic plates shifting along a fault line, or a meteor impact, or even a large explosion, the entire planet rings with vibrations that travel through rock and metal all the way to the core and back again. Scientists have learned to listen to these planetary songs with incredible sensitivity. They place seismometers, devices that can detect movement smaller than the width of an atom, in quiet locations around the world. These instruments are like Earth's stethoscope, allowing us to hear our planet's heartbeat and diagnose what might be happening in its deepest, most hidden places. The waves that travel through Earth behave differently depending on what they encounter along their journey. When they pass through solid rock, they move at one speed. When they hit liquid, they slow down and change direction. When they encounter something unusually dense, they bend and twist in characteristic ways. It's like watching ripples move across the surface of a pond. If there's a rock just beneath the water, the ripples change their pattern when they pass over it. Scientists studying seismic waves can detect similar changes as the waves travel through our planet, revealing hidden structures deep below the surface. Over decades of careful listening, scientists have used these vibrations to create detailed maps of Earth's interior. They've discovered that our planet has distinct layers, like an onion made of different materials. They found liquid iron oceans spinning in the outer core, and solid iron crystals at the very center. They've identified ancient slabs of ocean floor that have been pushed deep into the mantle, and traced the paths of underground rivers of molten rock. But here's where the story becomes truly fascinating for our mystery. If a tiny primordial black hole really does exist at Earth's center, it would create a unique signature in these seismic waves. The incredibly dense object would affect the vibrations in ways that nothing else could. Picture dropping a small, extremely heavy marble into the center of a ringing bell. The marble wouldn't change the bell's basic shape or stop it from ringing, but it would subtly alter the frequencies and patterns of the vibrations. Scientists studying Earth's seismic symphony might be able to detect similar changes if something as dense as a black hole were hiding in our planet's core. The challenge is that these changes would be almost impossibly small. The seismic signature of a mountain-mass black hole compressed into atomic dimensions would be buried beneath thousands of other signals, the constant trembling caused by ocean waves, the vibrations from traffic and machinery, the natural flexing of Earth's crust as our planet spins and orbits the Sun. It would be like trying to hear a single whispered word in the middle of a crowded stadium during an exciting game. But scientists love this kind of challenge. They've developed computer programs that can filter through years of seismic data, separating the signals they want to study from all the background noise. Some researchers are particularly interested in Earth's free oscillations, the natural vibrations that occur after large earthquakes. Just as a bell continues to ring for several minutes after being struck, Earth continues to vibrate in complex patterns for hours or even days after a major seismic event. These free oscillations are like Earth's natural singing voice. The planet vibrates at specific frequencies determined by its size, shape, and internal structure. If something unusual exists at the very center, something with different properties than the iron and nickel we expect to find there, it might change these natural frequencies in detectable ways. The search for these subtle changes requires incredible patience and precision. Scientists must study data from hundreds of earthquakes, recorded by thousands of seismometers around the world, looking for patterns that might reveal our planet's deepest secrets. They also use sophisticated computer models to predict exactly what kind of seismic signature a primordial black hole would create. These models simulate earthquake waves traveling through virtual Earths, some with and some without tiny black holes at their centers. By comparing the predicted patterns with real seismic data, researchers hope to find evidence of these ancient visitors. The work is made more challenging by the fact that Earth's interior is far more complex than a simple layered sphere. There are variations in temperature and composition throughout the mantle and core. There are currents and flows in the liquid outer core that change over time. All of these factors create their own effects on seismic waves. But this complexity is also what makes the research so exciting. Each new earthquake provides fresh data about our planet's hidden architecture. Each improvement in computing power allows scientists to create more detailed models of how seismic waves should behave under different conditions. Some of the most promising research focuses on the deepest earthquakes, those that occur hundreds of kilometers below the surface, where the pressure and temperature are so extreme that rock behaves in completely different ways than it does near the surface. These deep earthquakes create seismic waves that travel through the entire planet, sampling conditions all the way from the earthquake source to the opposite side of Earth. The waves from these deep events are like X-rays that can penetrate all the way through our planet, revealing details about the core that can't be studied any other way. If a primordial black hole affects the way these waves travel, it would show up most clearly in data from the deepest seismic events. As you drift toward sleep tonight, Earth continues its eternal song, ringing with vibrations too subtle for human senses to detect, but powerful enough to carry messages about the deepest mysteries our planet might be keeping. Perhaps somewhere in that planetary symphony, encoded in frequencies and patterns that we're only beginning to understand, lies the answer to whether we truly share our world with a visitor from the dawn of time. As you rest here in the peaceful darkness, something extraordinary is happening all around you, something so strange that it challenges everything we think we know about reality. In the space between your atoms, in the gap smaller than anything you can imagine, the universe is dancing to rules that seem more like magic than science. Welcome to the quantum world, where the impossible happens every moment of every day, and where the story of tiny black holes becomes even more mysterious and beautiful. At the scale of everyday life, things behave in ways that make perfect sense. A ball thrown across a room follows a predictable path. A book placed on a table stays exactly where you put it. The Moon orbits Earth in a steady, reliable pattern that we can calculate centuries into the future. But shrink down to the size of atoms and smaller, and the rules change completely. At this microscopic scale, particles don't have exact locations. Instead, they exist in clouds of possibility, being everywhere and nowhere until someone tries to measure them. It's as if reality itself is dreaming, and particles are the shifting, flowing images in that cosmic dream. Imagine trying to photograph a hummingbird's wings in flight. In regular photography, you'd capture the bird in one specific position at one specific moment. But in the quantum world, it would be as if the hummingbird's wings existed in all possible positions simultaneously, creating a blurred cloud of potential wing locations, until the moment you took the picture and forced the wings to choose where to be. This strange behavior isn't just a curiosity for scientists to study. It's the fundamental nature of reality at the smallest scales. Every atom in your body, every particle of air you breathe, every photon of light that ever touched your skin, all of them participate in this quantum dance of possibility and uncertainty. But here's where the story becomes truly magical. In the quantum world, empty space isn't really empty. What looks like perfect vacuum is actually buzzing with activity, filled with virtual particles that pop into existence and disappear again so quickly that they seem like ghosts. These particle pairs appear from nothing, dance together for the briefest instant, and then vanish back into the quantum foam from which they came. Scientists call this the zero-point energy of space. Even when you remove all matter, all light, all heat from a region of space, it still contains this fundamental quantum energy. It's as if the universe cannot bear to be completely empty, so it fills every void with these flickering, temporary particles. Now imagine what happens when this quantum dance encounters something as extreme as a black hole. The strange rules of quantum physics suggest something almost impossible, that black holes themselves might flicker in and out of existence at the smallest scales, like fireflies blinking in a summer meadow. These quantum black holes would be far tinier than even primordial black holes. They would exist for such brief moments that calling them holes seems almost wrong. They would be more like quantum hiccups in spacetime, tiny regions where gravity becomes so intense for such a short time that they create microscopic event horizons. Picture soap bubbles forming and popping on the surface of boiling water. The quantum black holes would be similar, except instead of bubbles in water, they would be bubbles of intense gravity appearing and disappearing in the fabric of space itself. Most would vanish almost instantly, existing for time periods so short that we don't even have proper names for such small fractions of a second. But occasionally, under exactly the right conditions, one of these quantum fluctuations might last a little longer. It might capture just enough energy from the surrounding quantum foam to stabilize itself, to grow from a fleeting possibility into something more permanent. This is one way that primordial black holes might have formed in the early universe. In the incredible density and energy of those first moments after the Big Bang, quantum fluctuations might have been amplified by the extreme conditions, allowing some of these microscopic gravity bubbles to grow into stable, long-lasting objects. The quantum world also suggests something beautiful about the black hole that might exist in Earth's core. Even if such an object is stable and long-lived, it would still be connected to the quantum foam around it. Virtual particles would still appear and disappear near its event horizon, creating a subtle glow of radiation that exists in the boundary between matter and pure possibility. This radiation would be incredibly weak, far too faint to detect with any current technology. But it represents something profound, the idea that even the darkest objects in the universe are not completely black. They participate in the quantum conversation that fills all of space, giving off gentle whispers of light that connect them to the fundamental energy of the cosmos. In the quantum realm, the act of observation changes what we see. This isn't because our instruments are clumsy or our measurements disturb delicate systems. It's because quantum particles genuinely don't have definite properties until something interacts with them. They exist in what scientists call superposition, being in multiple states simultaneously until the moment of measurement forces them to choose. This raises a beautiful question about our hypothetical primordial black hole. In some sense, until we find a way to detect it, it exists in quantum superposition, simultaneously there and not there, real and imaginary, affecting Earth's core and having no effect at all. Perhaps this is the deepest mystery of quantum mechanics, that reality itself might be fundamentally uncertain, with definite facts emerging only when the universe observes itself through conscious beings like us, asking questions and seeking answers. The search for primordial black holes is really a search for the boundary between the quantum world and the classical world we experience every day. It's an attempt to find objects that were born from quantum fluctuations but grew large enough to become part of ordinary, predictable reality. If such objects exist, they would be living bridges between the two realms of physics, quantum and classical, microscopic and macroscopic, possible and actual. They would be proof that the strange rules governing the world of atoms can sometimes reach up and touch the world of planets and stars. As your breathing slows and your mind drifts toward sleep, quantum particles are dancing in the space around you, appearing and disappearing in an eternal ballet of possibility. Virtual particles are popping into existence in the air above your bed, living their impossibly brief lives before vanishing back into the quantum void. And perhaps, in the deepest place on Earth, something born from this quantum dance has found a way to become permanent, a tiny piece of cosmic mystery waiting patiently to be discovered. The boundary between dreams and reality becomes beautifully blurred when we enter the strange realm where the smallest things in the universe dance with the largest. As you settle deeper into the soft embrace of your bed, let yourself feel grateful for something truly wonderful. Tonight, you live in a universe that still holds mysteries. You exist in a cosmos that refuses to reveal all its secrets at once, keeping some of its most beautiful possibilities wrapped in gentle uncertainty. This is not something to fear or feel frustrated about. This is something to celebrate. In a world where we can instantly find answers to so many questions, where satellites map every corner of our planet and telescopes peer into the farthest reaches of space, it's remarkable that profound mysteries still exist right beneath our feet. The question of whether a tiny black hole lives in Earth's heart represents something precious about human curiosity and the nature of discovery itself. We have traveled to the moon, sent robotic explorers to other planets, and detected gravitational waves from colliding black holes billions of light years away. Yet we still don't know for certain what exists at the very center of our own home. This beautiful ignorance reminds us that science is not just a collection of facts to memorize, but an ongoing conversation with the universe. It's a gentle dialogue between human curiosity and cosmic mystery, where each answer leads to new questions, and each discovery opens doors to rooms we never knew existed. Consider how far we've come in understanding our world. Just a few hundred years ago, people thought Earth was flat and motionless at the center of everything. They believed the stars were tiny lights painted on a solid dome above our heads. They had no idea that atoms existed, or that light could behave like both a wave and a particle, or that space and time were woven together into a single fabric. Yet with each generation, patient observers and creative thinkers have peeled back another layer of mystery. They've discovered that Earth is a sphere spinning through space, that stars are distant suns burning in a vast cosmic ocean, that matter is made of particles so small they seem more like mathematical ideas than physical things. And still, after centuries of discovery, the universe continues to surprise us. Dark matter and dark energy make up most of the cosmos, yet we can't see them directly. Quantum particles behave in ways that challenge our basic understanding of reality. And perhaps most wonderfully of all, tiny black holes from the dawn of time might be hiding in the most familiar place imaginable, right here beneath us. The search for primordial black holes teaches us something important about the rhythm of scientific discovery. Progress often comes not in sudden flashes of complete understanding, but in gradual accumulations of evidence, patient observations, and carefully crafted experiments that slowly narrow down the range of possibilities. Scientists studying this mystery know they might spend entire careers searching for something that doesn't exist. But they also know that the search itself is valuable. The instruments they build to look for primordial black holes help us understand earthquakes better. The mathematical models they create teach us new things about how gravity works. The underground laboratories they construct reveal secrets about particles from distant stars. This is how science really works. It's not about having all the answers, but about asking better and better questions. It's about building tools that can detect things we've never seen before. It's about being comfortable with uncertainty while still pushing gently against the boundaries of the unknown. There's something deeply comforting about living in a universe that still holds secrets. It means there will always be new discoveries waiting for future generations. Children born today will grow up to explore mysteries we can't even imagine yet. They might find definitive proof that primordial black holes exist in planetary cores, or they might discover something even stranger and more wonderful. The universe seems designed to reward patience and curiosity. Just when we think we've figured out how something works, it reveals new layers of complexity and beauty. Black holes, which once seemed like pure science fiction, turned out to be real and even stranger than anyone had imagined. Quantum mechanics, which sounds impossible, turns out to describe reality at its most fundamental level. Perhaps the most beautiful aspect of our current ignorance about Earth's core is how it connects us to the long history of human wonder. Every person who has ever looked up at the stars and wondered what they were, every curious child who has asked why things fall down instead of up, every scientist who has spent long nights in a laboratory searching for answers, all of them are part of the same great adventure. You are part of this adventure too. By wondering about tiny black holes in Earth's heart, by letting your imagination explore the possibilities, by feeling amazed at the strangeness of reality, you join the countless generations of humans who have found joy in not knowing everything. Tomorrow, scientists around the world will wake up and continue their patient search. They'll analyze new data from seismometers deep underground. They'll refine their computer models of how primordial black holes might behave. They'll build more sensitive instruments to detect gravitational waves. They'll ask new questions and dream up new ways to find answers. And someday, perhaps decades from now, someone might finally discover the truth. They might find compelling evidence that a visitor from the dawn of time really does live quietly in Earth's molten iron heart. Or they might prove beyond doubt that no such object exists, solving the mystery by showing us what isn't there. Either discovery would be wonderful. Either answer would teach us something profound about our universe and our place within it. Because in the end, the joy is not just in finding answers, but in the search itself, in the willingness to ask questions that might not have easy solutions. As sleep begins to take hold of your mind, you can rest peacefully in the knowledge that mystery still exists in the world. You live on a planet that might harbor impossible secrets, in a universe that continues to challenge and surprise us. And in your dreams tonight, perhaps you'll explore realms even stranger and more wonderful than the hidden heart of our own Earth, where the only limits are those of imagination itself.